So, Assalamualaikum and selamat sejahtera. Today I am going to be presenting my group's SEL project or poster with the topic for water analysis. So the focus topic that we use is the underground and drinking water contamination in Chandigarh in India. So let's start with the causes or objectives of this study. So the investigation was to assess the quality of water and monitor the levels of various parameters in the drinking and underground water samples of Chandigarh and also the nearby regions of Chandigarh. So the method used is it was carried out using a thermo-scientific trace, also a thermo TSQ 800 triple quadruple MS. Right. So the pollutants can be broken down into 4 parts. There's industrial waste, which includes heavy metals, chemicals, and also various organic compounds. We've got agricultural runoff, fertilizers, pesticides, and also herbicides from nearby plantations and such. And then we also have sewage and wastewater. So inadequate sewage treatment can also be a pollutant to the water supply. Next is also the solid waste disposal. So this is like mostly domestic waste from people's families and homes that they just they might throw rubbish into the same water that they use for drinking and other stuff. Right, so we move on to our data analysis, which we use various parameters of different sample locations as well. So the percentage of samples having different, firstly pH. So pH is a measurement of either the acidity or alkalinity of water, right? Or any liquid for that matter. So for water, it usually needs to be neutral, around 7. 7 is good. Alright, so next is also TDS, which is the total dissolved solids. So this is the amount of solids that are dissolved inside the water. Lower is better. Next is hardness. So hardness is the amount of magnesium and also calcium inside the water. So too much water hardness can cause a lot of problems, especially if you use it for from what I know is if you use it for your hair, it can cause it to be like really dry and unhealthy. Right. So next is BOD, which is the biochemical oxygen demand. So this is the amount of oxygen that is required by microorganisms inside the water, right? So usually a lower BOD or biochemical oxygen demand is better, meaning there's less microorganisms inside the water. Next is also DOs, similar to the BOD, is dissolved oxygen, lower is better. And also F, which is EC, electrical conductivity. So usually the amount of electrical conductivity should not exceed 400 microsiemens per centimeter cube. Right. So next we move on to the chromatogram of a standard reference of firstly ES, which is effluent standard, HCH, which is hexachlorocyclohexane, and also third, we took a water sample from the tap as well. Alright, so next we move on to suggestion to prevent. So to prevent water contamination, right? So the treatment of domestic sewage water should be done. Sewage should be treated, and the water should be reused back and put back into the system, right? Next is regular monitoring and testing will allow for timely and corrective action. So regularly testing waters that are being used by everyone, like domestic waters, which are used for domestic use, right? It needs to be tested regularly. So if anything goes wrong or if there is some contamination, it can be found out very soon without any outbreaks of health problems coming out. Right, so strict industrial regulation prevent release of harmful chemicals. So I think most people know that usually inside domestic uses, they're not really the problems that cause these that cause the water to be infected by chemicals or such. Usually it's these big plantations or factories that do cause the waters to be affected by these contaminants, right? So what is next we move on to the best treatment for water. So what is the best water treatment that can be implemented? First, we can do coagulation and flocculation. Second, we've got filtration. So this is just to filter out the solids and such. Next is disinfection, which usually is done chemically using chlorine. Even our country, Malaysia, does this as well for our water, and we also reverse osmosis to end the whole procedure. Right, so a lot of countries, mostly developing and also developed countries, do use this whole process to cleanse the water and also reuse the water back for domestic and also industrial use. Okay, so next we move on to the conclusion. To summarize, underground water in Chandigarh, India, is not safe for daily consumption, just based on the data that was taken, right? Based on the pH, TDS, and hardness that was previously mentioned. So the water is not safe for daily consumption. So it has a significant amount of concentration in COD, the chemical oxygen demand. Right, so that means there's a lot of microorganisms living inside the water, which is not usually what is aimed or is looked for. The site that was being used for agricultural purposes, it poses a threat to public health. So there is an agricultural site nearby where the samples were taken. So I think a lot of the pesticides or the fertilizers used may have leached into the source of the water, right? So it does pose a threat to public health. So to ensure the safe drinking water, it is generally advised to rely on treated and properly tested water sources. So if in any sense that we can't be able to drink this type of water, we need to look for alternatives, right? So maybe bottled water or water from other sources, right? I think that's it for my presentation on our poster. Right, hope you enjoyed. Thank you.